Okay, in this lecture we're going to talk about rational equations, and they're rational equations that will lead to a linear equation that we need to solve, and rational equations that will lead to quadratic equations that we will need to solve. So I'm going to look at both of these cases. A rational equation, of course, is an equation that involves fractions. Okay, and so let's have a look at an example of one. Alright, and so let's suppose we want to solve, okay, part A. Let's suppose we have 2x minus 3 over 2 plus 5x over x plus 1 equals x. Right, so we have a rational equation because we have these rationals here, 2x minus 3 over 2 and a 5x over x plus 1. Now the first thing to note, alright, number one, check for values we cannot have. Because whenever we're dividing by things, there are things that could pop up as 0, and we can't have that. And notice that this one here, alright, has x plus 1, and we can't have this to be 0. So notice that in this case x plus 1 can't be 0, so in fact x cannot be equal to negative 1. So we need to keep that in mind, alright, as we look for the solution in case that solution comes up. And it can't really be a solution, so it won't be a solution. Right, now whenever we're adding fractions, we always need a common denominator. So we might want to think about x here being x over 1. So we look for a common denominator, which of course will be the product of these. Now the 1 doesn't really matter, but we could have a 2 times an x plus 1. So what I'd have here is 2x minus 3 over 2, and I'd have to multiply the top and the bottom by x plus 1 to get my 2x plus 1 plus 5x here over x plus 1, and I'd have to multiply the top and the bottom by 2 to get my 2x by x plus 1. And here of course we would have to do 2 by x plus 1 on the top and the bottom, and so we end up with this. Right, so now we have 2 by x plus 1 is going to be my common denominator, and here I'm going to have 2x minus 3 by x plus 1 plus 10x, and over here we're going to have a 2x by x plus 1 over 2 by x plus 1. Right, now notice that we have the same denominators on both sides, and if these two are going to be equal, then the numerators need to be equal as well. So I'm going to FOIL this one out. So I get 2x squared plus 2x minus 3x is minus x, minus 3 plus 10x is equal to 2x squared plus 2x. Right, so this implies then, if I subtract 2x from both sides, I'm going to have 10x minus x is going to be 9x minus 3 is equal to 2x. So in other words, we have subtracting 2x from both sides, and of course adding 3 to both sides, I'll end up with 7x is equal to 3, which implies that x is equal to 3 over 7. Alright, so that appears to be my solution, and we should check now to make sure that it is. So always check, alright, by putting 3/7 back inside of this. So I get 2 by 3 over 7 minus 3 over 2 plus 5 by 3 over 7 by 3 over 7 plus 1. Is this equal to, alright, 3 over 7? And we find that it is, yes, and so our solution is in fact 3 over 7. Okay? Right, part B. Let's suppose we want to do this one. We have x over x take 5 plus 5 equals 5 over x take 5. Right, once again we look for things that we don't allow here, and of course we can't allow 5 here, so x cannot equal 5, so we need to keep that in mind. Okay, right, now we need a common denominator, so it looks like x take 5 is going to be the common denominator. So this one we're going to need to multiply x take 5 by x take 5, notice we're just really multiplying by 1 here, equals 5 over x take 5. So this is going to imply then, since x take 5 is going to be the common denominator, we're going to have an x here and a plus 5 by x take 5 here is going to be equal to 5 over x take 5. Right, now notice that the denominators are the same, and so the numerators must be the same. So I have x plus 5x minus 25, if I distribute the 5, is equal to 5. Which implies, of course, that 6x is going to be equal to 30, right, which means x is going to be equal to 30 over 6, which is equal to 5. Alright, however, right, we're not allowed to have x equals 5, so x equals 5 cannot be a solution. We know we have no other choices, so there is no solution. Alright, so we either put it as an empty set or we use this symbol here, meaning a null set. Okay, and so there's two examples of rational equations and how to go about doing them. And this was a linear case because it led to actually the formation of a linear equation right here, and of course a linear equation right here. Okay,